a triangle, is a segment from a vertex to the midpoint of the opposite side. Okay, so in this case, if I look at D, F, and E, how do I know that D, F, and E are all midpoints of each one of those three sides? Okay. So, but E doesn't necessarily have anything to do with P though, right? What do I know? As I look at this triangle, how do I know that E is in the middle of side BC? What kind of markings are they telling us? These are congruent, right? We know these two are congruent, we know these two are congruent, which tells us F's in the middle, and we know these two are congruent, so that tells us D's in the middle, okay? So those points don't necessarily have anything to do with P, but if I connect A to this midpoint, and I do that for all three sides, then we're given a point in the middle here, P, and we're going to say that P is the centroid of this picture, okay? So we're connecting the midpoint of a side to the angle that is opposite of it. That is what we call the median of a triangle. When we connect all three of these medians together, we have a point in the middle where they intersect. Okay, the centroid is that point, in this case P. Okay, now there's some relationships here, and these relationships are a little bit different than yesterday. Yesterday it was just like, we talked about the circumcenter, we talked about the incenter, and we had pieces that were congruent. Well, these pieces are not congruent today. If I look at PE and I look at PA, those two pieces are not congruent, okay? These are not necessarily going to be congruent, okay? So we're not necessarily going to talk about congruency today. The thing that we're going to look at here is AP, the length of AP, is 2 times bigger than PE. So if I told you that this was 3 units long, this would be 6 units long, okay? If I told you that this piece here was 4 units long, this would be 8 units long. So the longer piece is going to be 2 times longer than the shorter piece of that median. So P is going to split it, but it's not going to split it necessarily in half. It's going to split it into a 1/3, 2/3 relationship. And so we're going to use fractions to represent that, but I'm going to show you easier ways to come up with that, because sometimes when we see fractions, we get freaked out and we're like, oh my gosh, we got fractions. How are we going to solve this? I'll show you a simpler way that you can do this. So AP is 2/3 of AE. And so what we're basically saying is that if I have 3 sections here, AP is 2 out of those 3 sections, which means PE would be 1/3 of those sections. So I could also say PE is 1/3 of AE. Okay, so 2/3 and 1/3 make 1. It makes the full length. We could do the same thing for the other 2 medians. BP is the longer piece. We have BP and we have PF. BP is the longer one, so BP would be 2/3 of BF, which is the entire length. And then we same thing here. CP is longer than DP, so CP is going to be 2/3 of CD. Okay, and I could do the same thing here for 1/3 if I wanted to, but they're all going to be in a 1/3, 2/3 relationship. But the easiest way to remember it is that this piece is 2 times bigger than this. So we have to kind of use that information to help us figure this out. Okay, so if we go down here, and I'm going to show you some ways that we could go about this. We have a triangle, okay? Triangle RST, and it tells me that Q is the centroid, okay? So what that tells me, in this case, is that Q, P, and this point here, which isn't labeled, are all midpoints of their sides. Now the one that we're given is SQ. So which one's longer, SQ or QW? SQ is longer, right? So based on what we just talked about, the longer piece is always 2 times longer than the shorter piece of that same median. So if this is 8, what do we think QW has to be? going to be half of that, right? It's going to be 4, okay? So we know that SQ is 8. So to find QW, it's going to be half of 8, or 8 divided by 2, which is 4. The third piece it wants me to find is SW. Well, if this is 4 and this is 8, then how do I find SW? Add them up, right? We know the two pieces, so just add the two pieces together, and we get 8 plus 4, which is 12. Okay? So we really don't have to use any fractions there, right? We don't really have to use any fractions. You might say, well, you have a fraction here. Yeah, half of 8 is the same as 8 divided by 2, though, right? So could I just divide by 2? Absolutely. If I know the longer one, I divide by 2. If I knew the shorter one, I would multiply by 2. Okay? And that would be kind of the shortcut that you would have to go here. You wouldn't necessarily have. Now, if they give me the full length, I'll show you what we would do in that case. Okay, same thing down here. We have LMN as a triangle. QN is the entire length here. Okay, QN is 12. I want to find PN and PQ, or QP. So the one I always like to do first is I like to find the shorter one. QP is shorter than PN, right? And I know this one's 2 times bigger than this. So once I find the short one, all I got to do is double it to get the long one, right? So this is a third times 12. But if I take a third of something, if I split something into thirds, then all I'm doing is dividing it by 3, right? If I take a pizza and cut it into thirds, that means I have 3 equal slices, okay? And that's what I'm doing here. I'm taking that segment and I'm cutting it into 3 equal parts. So I take 12 times a third, or the easier way is just to divide it by 3. So PN is 4. So then what would QP have to be? How much longer is, oh, sorry, QP, I wrote these down wrong. PN is the longer one, so that's my fault. I should have put all of this over here. QP is the shorter one, so QP would be 4. So then PN would be 8. It would be 2 times 4. And the one thing you would always want to check then is that these two answers should together make 12. 8 plus 4 makes 12. This one's 2 times bigger, and they add up to be 12. If those numbers check out, everything's good. Okay, this one here. There are 3 paths through a triangular park. So we got this park that makes a triangle with this path that goes around. Each path connects the midpoint. Okay, so we know that T, S, and R are all midpoints. Nowhere does it ever say that this is the centroid of this picture, okay? But because we know T, S, and R are the midpoints of each of those sides, then we know that P is the centroid. Because it's where those medians all intersect one another, okay? So it doesn't just come right out and say, boom, it's the centroid, but we can get to that point by knowing that. Okay, the paths meet at point P, which we just said was the centroid. Find PS and PC when SC is 2100. So SC is 2100. I want to find PS and PC. Okay, so as I look at this segment right here, which one's longer, PS or PC? PC, okay? PC is longer than this. So we know this one's 2 times bigger than this one, right? So we're going to find the shorter one first. The shorter one is PS or SP. So we're going to take 2100 and divide it by 3, because we're breaking it up into 3 sections, essentially, which would be 700. Okay, and then what do I have to do to get PC? What do we know about that relationship? How much bigger is it going to be? 2 times bigger, right? So if PS is 700, PC would be 1400. Does 700 and 1400 make 2100? Yeah, okay. And that's how we can double check to make sure our math is good here. Okay. It goes on to say what happens if SC is 1200. So it's not changing the side, it's just changing the length of SC. If SC was 2100, then we can do it. We're still finding PS and PC. So it's just doing the same problem 3 times. All we're going to do, same thing, okay? The number changes. I start with 1200 this time. To get PS, I'm going to take 1200 divided by 3. Which is 400, okay? And then to get PC, what are we going to do? Times by 2, which is 800. 400 and 800 should make 1200, which it does. And then it said, what happens if SC is 900? So we're going to do the same thing. PS, PC. For PS, we're going to take 900 divided by 3, which is 300. And then we're going to double it, which is 600. Okay? And always double check to make sure these two add up to be that. If those two don't add up to be 900, then my math's gone wrong somewhere. Now, I know this one is not at the bottom of your page, but I want to talk about this because kind of like yesterday, you're going to see one like this on Big Ideas, and I want you to I'm going to redraw this. And you can do this at the bottom of the page or anywhere you can find some space. This is triangle LMN. Okay, if I were to connect these 3 together to the different midpoints, okay? R is the midpoint of this side. If I connect it to the angle or the vertice opposite of it, I would have RL, okay? These 3 points all intersect right here. So I would say C is the centroid. Okay, now in this case, if I tell you that QP, or QC, I should say, is x plus 2, and I tell you that NC is 3x minus 7, and I ask you to find QN. Okay? This is an algebra problem. We aren't given the actual lengths like we were on the last couple of problems. We're given expressions with variables in it. Okay? Now, first up, which one is longer here? We have QN. Is QC or CN bigger? Which one's a little bit longer? Because if it's a centroid, they can't be the same length. Is QC longer or CN longer? N. Yeah, CN, right? So this one is a little bit longer than this one. And the relationship that's always going to be true today is this one's going to be 2 times bigger than this. Okay, so the way that I'm going to write this is I'm going to say QC times 2 equals NC. I'm going to double this length, get it here. If I told you this was 5, this would be 10, right? The only way we've done it so far is with numbers. Now we have expressions, now it's a little bit trickier, okay? But I tell you up here what QC and NC are. So we're going to take QC and we're going to plug it in right here. So QC is really x plus 2. NC is 3x minus 7. So 2 times this is equal to this. Same thing we were doing before, but now we do it with expressions. Okay, what would we do first here? Think about algebra stuff. Distribute, right? We see parentheses, we know we got to distribute. So we got 2x plus 4 equals 3x minus 7. And now we saw this a lot yesterday. We're going to subtract 2x. We're going to add 7. And we get 11 equals x. Okay, but I asked you up here to find Qn. So I'm going to take 11 and plug it into this one, which is 13. I'm going to plug 11 in here. 3 times 11 is 33. 33 minus 7 is 26. Okay, now, watch what happens here. Is this one 2 times bigger than this one? Yeah, it better be, right? Because we said that's the relationship today. If this is not 2 times bigger than this, then we have done something wrong. Okay? But pay attention to what it's asking you to find today. It may ask me to find QC, it may ask me to find NC, but this one's asking me to find QN, which is the entire piece. So what do we got to do with these two? Add them up. Okay? So QN would be 13 plus 26, which is 39. Okay? So pay really close attention to what it is they're asking you to find. So not much difference there, but you have, that would be the easiest way to go there. Don't try to use fractions. Fractions are going to confuse you more. Try to write an expression out that makes it easiest to solve. I didn't even use a single fraction in there. Okay, and so try to stay away from those fractions at all possible. Okay, we're not going to talk and do much with the orthocenter, but we are going to talk about what it is. So first of all, altitude. Altitude is another way of saying height in geometry. Okay, and you might say, well, why don't we just talk about it being the height? Because it may not be a part of the triangle itself. Altitude is how tall it is from base to the top of the figure. It's the perpendicular segment from the vertex to the opposite side or to a line that contains the opposite side. So in this case, the altitude is inside of the triangle, right? I'm going to draw a line from Q down. So here, my altitude's on the inside of the triangle. Here, I can't draw on the inside of the triangle because I would have to connect P up to here and there's no point there. So my P, because this is an obtuse triangle, this one is an acute triangle. This one is an obtuse triangle. Here, my altitude is outside of the triangle. So what we did was we extended this side a little bit. It's still not part of the triangle, but we extend it so we can draw that perpendicular height down. So this right here would be my altitude because it's the perpendicular height from the top point to the base or the bottom. The other one, and this one's not on here, but what if I had a right triangle? What would my altitude be? It's a short leg. Yeah, it's this guy right here. Okay, so it's actually a side of the triangle. So this part right here is my altitude. Okay, the difference with all three of those is that obviously we have a different kind of triangle. We have a right triangle, an acute triangle, and an obtuse triangle, but the altitude's different in all three cases. This one is part of the triangle, this one's inside, this one's outside. So my altitude's in different places based on the type of triangle that I have, okay? But all three of those have an altitude. Anytime you have a triangle, you'll have an altitude. It just depends on where it's at based on the type of triangle that you have. Okay, so here's our fourth different type of center. We have in-center, circumcenter. We had centroid, which is kind of a center. It's on the inside of the triangle. And now we have what we call the orthocenter. And I told you yesterday that the hardest part is to try to keep all of these separate. And tomorrow when we review, we'll kind of talk about how we can kind of know which one's which and what we're going to do. The point where the three altitudes of a triangle meet. And when we talk about the three altitudes, I'm going to draw three altitudes in here because I'm going to connect C, and it's going to be perpendicular to the opposite side of the triangle. And I'm going to do that to all three. Now, notice it's not necessarily splitting the triangle in half, right? Like this one here, AE and BE are definitely not the same length. But the only thing that we have to draw is we have to draw to make sure that it's perpendicular to the base. And we do that for A down to F, which is perpendicular to BC. And then we do B to D, which is perpendicular to AC. So we have three perpendicular segments going from a vertice to the opposite side. Okay, so everything's different based on what we're doing with that. So this right here, G, is what we call the orthocenter of this triangle. Okay, draw in and label the median and the altitude of each triangle. Okay, I know that this one is not given to us here, but this is a right triangle. So based off what we said just a few minutes ago, this right here is my altitude. If I wanted to draw in the medians of this one, the median connects to the middle of the opposite side. So I'm going to kind of eyeball about where the median or the middle would be, and I'm going to connect it to the opposite vertex. So all I'm going to say here is that these are the median, and there's three of them, okay, because we're going to connect the opposite vertex to the opposite side. So we actually have three different medians here. If I was going to draw the altitude down to the middle of this base, this is perpendicular, okay? And that altitude is also the median because it splits that opposite side in half. It's the perpendicular bisector to this side. So the altitude and the median could be the same figure. If I say altitude and you say median, we might be talking about the same segment. We're not talking about the same thing on this picture, but on that middle picture, we are. Now, if I drew in the other two medians, those would not be the altitude. Those would be my other two medians, but they are not the altitude. So one of the medians is the altitude, the other two are not, because they're not perpendicular to the base. Okay. So once again, we still have three medians, but only one of those medians is the altitude. Okay, this last one kind of like we said up above. The altitude here has to be on the outside of the figure because we have an obtuse triangle. Okay, we cannot draw the altitude on the inside because of the fact that it's an obtuse triangle. So my altitude is that piece right there. It's not actually part of the triangle. It's actually outside of the triangle. So as we said before, here the altitude is part of the triangle. Here it's on the inside of the triangle and it's the same as the median. Here it's on the outside. if I were to draw my medians in here, once again, we're going to kind of eyeball about where we think the middle of those sides would be. We're going to connect it to the opposite vertex. And once again, those three would be my median. And once again, we have three of them. Okay, so we'll have three medians whenever we draw that in. There's only one altitude. Okay, you just draw that altitude down to be perpendicular. Okay, the last thing, this kind of puts all the stuff together in one spot. Everything that we talked about yesterday and today, I know all of those are kind of confusing because they all talk about something being in the center. These two we did on 6-2. These two we did today, okay? But this puts them all in one spot, so you don't have to flip back and forth from your notes. The top two were from 6-2. The bottom two are from 6-3. We're just putting all of that information onto one page, so it's a little bit easier to understand the difference between all four of those. If you need to look back and see what is a centroid, you could look here and say, okay, here's a centroid. The centroid connects the medians of the triangle, okay, and talks about what it does. All right, that's all we got.